All right. All right. So the first thing that I saw, and I had a surprising number of people do this on the top right one, we distributed the minus through. So we got like 3 plus 2i and had minus 2 plus 5i, and then you proceeded to multiply. That doesn't magically turn this into multiplication. Now you just add them. Add them together, then it's combined like terms. Okay? So once we distributed that minus sign, I had a lot of people multiply that out. Combine like terms. That's why I never put any names on these. I'm not calling anybody out. You won't call yourself out. That's a whole other thing. But I ain't calling you out. And it happened to a lot of people. If it shows up on this board, it happened on seriously more than one. On this bottom one, this left-hand one, we're simplifying. We need to get the I out of the denominator. Cannot just multiply by I. We have to use the conjugate. 2 minus 3i over 2 minus 3i. I had a lot of people either do 2 plus 3i over 2 plus 3i and perfect square it, and we still wound up with i's in the bottom, and then we got very confused. Or we just multiplied by I. And then straight up ignored things. So it was kind of some strange choices got made. So make sure we're practicing using this conjugate where we take 2 minus 3i and 2 minus 3i. Because when we multiply those denominators together, we get 4 plus 6i squared minus 6i squared, so they cancel out, minus 9i squared. So our denominator becomes 4 plus 9. That's the point, is to get the i's out of the denominator. If we choose anything other than our conjugate, it's not going to get rid of the i's in the denominator. So the numerator we multiply like normal, and we're going to have i's and I squareds and all kinds of weird things. But it's important that the denominator not have i's in it. I'm not doing the whole thing because I want to have enough time for what we're doing today, but just kind of hitting the vibe. And then on this radical one, y'all made this way harder than you needed to for sometimes. Because I had a lot of people just do that and square it. Get the square root by itself first. Don't square it right there. Subtract x from both sides. Square root of 3x plus 2 equals 4 minus x. Now I can square it to get rid of that square root. Get the square root by itself before you try and square stuff. Otherwise, you wind up with a square root left and you had to do it again anyway. And then you wind up with x to the 4th and it's gross. Okay? A lot of you guys wound up trying to make things way harder than they needed to be. Questions on any of these three? Okay. We're going to do 2 more from 2.6. This is the end of 2.6. And then we're going to get into 2.7 today. So we're going to talk about our inequalities. We're going to be solving stuff. We got inequalities and absolute values and weird things happening. Two 7 is the last section of this chapter. So we're going to start 2.7 today and finish tomorrow. What's up? Do you have study halls? What period? Okay, I'll write you a pass. Remind me at the end. I'll write you a pass and you can come and take it today. All right, so our first one here, we have the absolute value of 2 minus 3x over 5 is greater than or equal to 2. So the distance, absolute value is a distance, remember? that chunk has a distance of more than 2 from 0. So if we think about it, because we haven't done a greater than yet, aside from that table, if we think about what this is saying, is this chunk either needs to be equal to or greater than 2, or equal than or smaller than -2, right? You see that? That's usually a sticker point. You see that? Awesome. So we're going to set this up as 2 inequalities. This piece either needs to be greater than 2, or this piece needs to be less than or equal to -2. So we're going to need to make 2 inequalities. So my 2 minus 3x over 5. What's up? Okay. Either needs to be less than and equal to -2. That's that left piece. Or my 2 minus 3x over 5 is greater than or equal to +2. Setting it up as 2 inequalities. So I'm going to work the left one first. So this blue one. What are we going to do over here to solve this first? Multiply by 5. Multiply by what's in our denominator. Because then my denominator cancels out and we're left with 2 minus 3x is less than or equal to -10. Ooh, that's small. Sorry, I'll write bigger on the next line. Then what are we going to do? It was very quiet, but I heard it. We're going to subtract 2. All right, so we're going to have minus 3x is less than or equal to -12. What are we going to do next? Divide by -3. And that's going to make me switch my sign because we're dividing by a negative number. So my x is going to need to be greater than or equal to +4. Questions on any of those pieces? Same vibe down the right-hand one. In fact, it's the exact same steps as well. Because again, on this purple one, my first thing is I need to get rid of that denominator. So we're going to multiply by 5 to both sides. To get our 2 minus 3x is greater than or equal to 10. And again, we're going to subtract our 2 from both sides. And we're going to start to notice our values be different. We have minus 3x is greater than or equal to 8. Again, we're going to divide by our -3, which is going to make my sign change. So we have that x has to be less than or equal to -8/3. So if we think about what this would look like on an inequality, or like on a number line, if I was to sketch this out, which I'm going to not use the blue so I can use that when I'm coloring. We would have that my x has to be greater than or equal to 4. So that's going to be over here and bigger. Or my x has to be less than or equal to -8/3. So it's over here. So they swapped sides. And I know I'm super small because I have one more line to write. Because we're going to write this into our interval notations. So we like to go from left to right, which is why sometimes putting it in the number line helps, because this one is actually smaller than this one. How are we going to put this piece as an interval? What's the smallest it can be? Negative infinity. So we're going to go from negative infinity to our negative 8/3. And I know I'm super right on the bottom here. I was going to say, are we going to use a parenthesis or a bracket on our 8/3? Bracket, because it's an equals to. If it has the equals to, we use a bracket. And then our right one, leave yourself a little space in between. Our smallest it can be is 4. Again, it can equal, so we use a bracket. And it goes to infinity. And if I have two pieces, and it can either be in the left piece or in the right piece, I have this or that, we're doing a union. So between them, you put a U. So you're right on the U. We just do need to have brackets too. So U for union means it could be in the left piece or in the right piece. Either way would give us a correct answer. Questions on this one, because this is a lot of stuff. Okay. Let's look at the right-hand one. What's up? More specific, where? Like up here at the beginning? Because it's an absolute value of 2. I know it's going to be out from 2. My distance here is greater than 2. It's more than 2 away from 0. So I need it to either be smaller than negative 2. That's this piece over here. That's this one. Or I need this absolute value to wind up being bigger than 2. So it's our absolute value that decides where we split it. We have to get our absolute value by itself first. Which provides a challenge on the next one. Because I have an absolute value in a denominator. Icky. Unfortunately, we can't just ignore it.
So we just make it one
We only split it when the absolute value is all by itself. Is my absolute value all by itself here? No.
We have multiple values.
Yeah. It's a fraction. I have something gross in the denominator. If I want to get rid of a denominator, multiply. So I'm going to multiply both sides by my denominator of absolute value of 5 minus 2x. Is the absolute value of 5 minus 2x ever going to be a negative number? Our absolute value is negative ever? So is it going to change my sign? No. So this piece and this piece cancel out. We're left with our 3 is less than 2 times our absolute value. And that's already less gross to look at. Still kind of gross. Sorry, sweetie, you in the wrong room for that then. Still kind of gross because it's math. Yeah, I can't help you there. I don't want to split it here yet. I need my absolute value all by itself before I can split it into its two possible options. So what are we going to do to get our absolute value all by itself? Divide by 2. So we're going to have 3 halves is less than the absolute value of 5 minus 2x. So my absolute value, that distance from 0, is more than 3 over 2. And again, if it helps, sketch it out on the number line because sometimes it's hard to spot. So 3/2 here. It could be that it's greater than 3/2 over here. That is absolutely one option. It could also be that inside that absolute value, it says negative 3/2. And in order for my absolute value to be greater than, it would need to be on this side. So that can help us figure out what's happening with our signs if it's not something we can spot with, like, in our heads. Because figuring out which piece goes with which sign is really important and really easy to get mixed and matched. So sketch it if it helps you figure that piece out. Because what we have is we're going to have that our 5 minus 2x might be less than negative 3 over 2. Or my 5 minus 2x might be greater than positive 3 over 2. It's headed outwards. Questions on the split on that part? Because I know that's a place where we commonly get stuck. Okay, so we're going to solve each of these individually. What are we going to do first? Minus 5. We're going to have minus 2x is less than what are we going to have? Negative 3/2 minus 5. Gross, right? It's like if you are one of those people who absolutely hate fractions, you can multiply everything by 2 and make it so you don't have fractions. But we can also do negative 3/2 minus 5. What is 5 in terms of halves? 10/2. So we have negative 3/2 minus 10/2. 13/2. Or you can multiply everybody by 2 and get rid of that fraction. That also would work just fine. What are we going to do next? Divide by negative 2. So that's going to switch my sign. What is negative 13/2 divided by 2? Super duper close. I'm with you on the 13/4, but what's our sign? Positive 13/4. I'm going to do the right-hand one with getting rid of the fraction first because I feel like that became our hang-up point here. Yes, dear? Because we had a negative 13 that we divided by negative 2. A negative over a negative. Is that the part we were asking about? Or is I thinking in the wrong place? At the top? Because of how absolute values work, it's going to either be this piece or this piece. So it's going to be right of 3/2, because then it could be greater than 3/2. Or if it's this way, it's smaller than negative 3/2. So if this chunk equaled negative 2, negative 2, absolute value would be positive 2, which is in fact greater than 3/2. So smaller negative numbers inside the absolute value will make your distance bigger. That help? A little bit. Okay, so on the pink one down here, let's get rid of that fraction because we got stuck on that. So I'm going to multiply absolutely everybody by 2 because I would really rather not deal with that fraction. So I'm going to make this be 10 minus 4x is greater than 3. I multiplied absolutely everybody by 2 to get rid of that fraction. And you can 100% do that. Because now what will we do? Minus 10. So we're left with negative 4x is greater than 3 minus 10, is -7, and that's a little bit easier to mental math sometimes. And so what's our x going to be? X is less than 7/4. I multiplied absolutely everybody by 2. That's where the 4 came from. I took this whole piece here, and instead of fighting with the fractions, I want to get rid of this fraction. So I multiplied this piece by 2, and I multiplied this piece by 2. That's a 2. So 2 different ways of approaching it. You can power through with the fractions, or you can multiply by your denominator, and you still wind up with the exact same answer. It's just a little bit more fractiony. And then our last step is to put it in its interval notation. So how are we going to write this in our interval notation? Which piece is smaller? My purple one here or my pink one here? And if we can't tell, sketch it. I'm going to give us a little bit more space, but that means I'm going to have to change the view. There we go, zooming it in. So when in doubt, sketch it out. If you're not sure, give yourself a picture. So I see that 13/4 it's going to be an open circle, and x is greater, so it's going to be this way. So x is bigger. 7/4 is smaller than 13/4, so it's going to be over here. It doesn't matter exactly how far, we're just giving ourselves a little sketch. It is also going to have an open circle because it doesn't have an equals to. And if x is less than 7/4, that means it's smaller than, so it's going to go this way. So this little sketch can really help us when we're putting it into interval notation. So how are we going to write this as an interval? To 7/4. Are we using a parenthesis or a bracket on 7/4? Parenthesis. Union. So joined with 13/4, which also gets a parenthesis, and it goes to infinity. Okay? Trying to get it out so we can see both of those. Okay, I wanted to make sure we practice some of those ones with fractions because we tend to get a little stuck on those. Okay. Questions? Because that is the end of 2-6. So you guys can now do everything in 2-6. But we're not done with the unit. We still have one more section. Because this has absolute values, it had some linears, but it never really went above that. So now we're going to look at more inequalities, but it's going to be things like quadratics and polynomials. Oh, yes.
This is making my stomach hurt.
It's okay. We'll get through it. All right. So we have 3x plus 1 times 5 minus 10x. It's because I haven't told you how to do this yet. That would be why. All right, so first things first, what shape is this? What would that look like if we were to graph it? It's a parabola, right? Not a square. This will look like a parabola, right? And we want to know when the parabola is greater than 0, right? So if we look at our little picture, which I'm going to change our zoom on it, we want to figure out where it changes from being less than 0 to being greater than 0, right? So what's an important place where it changes from being less than 0 to being greater than 0? It's x-intercepts. How do I find my x-intercepts on this thing? I was like, it's already in factored form, right? So, find our zeros. What are our roots? So find our roots for when it equals 0. It's already set greater than 0. So find our roots for when it equals 0. So 3x plus 1 is going to give us what root? Negative 1/3. Our 5 minus 10x is going to give us what root? Ooh, I heard both positive and negative 1/2. Which one?
Positive. Positive because you're going to...
Positive. Subtract the 5. Minus 5 equals negative 10x. Divide by the negative 10. So we have positive 1/2. So our two roots are going to be happening at our negative 1/3 and our positive 1/2. If we sketch it like this, we can start to kind of see what's going on, but I'm going to show you how to do this without sketching it because we're not always going to sketch it. Okay? Because what we're going to do here is I'm going to draw us a little number line. This is a structural number line. We need to have a number line here. And we're going to put our roots on it. So I'm going to leave a little space, and then I'm going to put my negative 1/3, and I'm going to put my positive 1/2. We're not doing any kind of scale. We're just kind of sketching it out. Because the problem with polynomials and quadratics is since I have those two pieces being multiplied, I have to try and figure out where the signs are being weird and where it's going to be greater than 0, so positive, or below 0, being negative. So I'm going to take each of my factors and write them here. So I'm going to take my 3x plus 1 and write it here. And I like to do it on separate lines on the paper like this. So 3x plus 1 on one line and my 5x minus, or 5 minus 10x, sorry. It was off the screen for me. On another line. And then right on my number line, right below it, I'm going to draw lines directly below my roots. So we're making kind of a little table. And we're going to look at each of these pieces individually. I promise it feels like we're overcomplicating it, but we're going to use this a bunch of times. Like we're going to use this when we're graphing. We're going to use it for this. I know we could sketch it, but I promise there's a reason. And what we're going to do is we're going to like substitute in values and see what would happen to the sign for each of these factors. So if we had an x value that was less than negative 1/3, what is something that's less than negative 1/3? Negative 2, negative 1. Anywhere in there, right? If my x was negative 1, would this factor be positive or negative?
0.
If x was negative 1, because we said that was smaller, right? So we're going to just think about it. If x was negative 1, 3 times negative 1 would be negative 3 plus 1 is negative 2. So if any x value this side of this root is going to wind up being negative, right? So we're going to put a minus sign in that spot. Even if it was negative 2 that you used, if you used negative 10, negative 500, whatever we put in that spot, that piece is going to be negative.
This is interesting.
I know, it's weird to wrap your brain around. I promise. There are reasons we do it this way. I promise, I promise, I promise. All right, what is something that is between negative 1/3 and 1/2? 0. So think about 0. So just into my blue one right now. If we substitute in 0, will this factor be positive or negative? Positive. Because 3 times 0 is 0. Plus 1 would just be 1. So this would be positive. And you don't have to pick a whole number there. If you want to go fractiony and wild, go for it. If you want to plug in a quarter, totally fine. If you want to plug in negative 1/4, also fine. We're just testing things. So then we need something bigger than 1/2. So in that other section, 1. So will this blue factor be positive or negative if I substitute in a 1? Positive. We're going to do the same exact thing with the green factor. If I use, and we can use those same values, that's why I put them here. So if we think about -1 and we substitute it in here, will this piece be positive or negative?
Positive.
What are we thinking?
Be positive. Yep.
Because it's going in here, right? -10 times -1 would be positive 10. Plus 5 would be positive 15. So this piece would be positive. If we plug in 0, what are we going to get here for our sign? Positive.
Let's just do all the positive.
What if we substituted in a 1? That would be negative, right? Negative or positive 1 times 10 would be 10. 5 minus 10 would be negative, right? Are we okay with those pieces? I know we're still really confused on the why the heck we just did that. So think back to how we make our quadratic. We multiply those two terms together. If this piece is negative and this piece is negative, they're going to multiply to be a positive number. If this piece is negative and this piece is positive, they're going to be a negative number. I now know all the places where it's going to change because we looked at our zeros. If I have a positive times a negative, is this going to be positive or negative total?
Negative.
Negative.
So that would be negative. In my center one here where I have a positive times a positive, is this positive or negative? Positive. In the right-hand piece, positive or negative? Negative. So my little sketch up here, I missed something. Because this really is negative, positive, negative.
Oh, so
It's upside down, which is part of the reason we don't sketch these to do that. I was just doing it so we had a visual. Okay, so which of these regions is greater than 0? The left, middle, or right? Middle. Greater than 0 means positive. So our solution is this space in between here. So it's going to go from our -1/3, our roots, our zeros, to positive 1/2. And what are we using? Parentheses or brackets? How do we know? Because it's parentheses doesn't actually count as a reason. Because it's not equal. We've got greater than, not greater than equals to. Yeah, so if we were going to color this on a number line, it would be these guys that would be above my y-axis. They would be greater than 0. Okay, so now that we've seen a whole one of those, questions? What's that? Mm-hmm. It's called a positivity table. So we take each of our factors. So 3x was 1, that was one of my factors. 5x or 5 minus 10x was my other factor. And we were finding the signs of each of those on either side of all of our zeros. So that we could find the positivity of our function. Because if I know the positivity, I can tell where it's above 0 or below 0 for my inequality. We're going to do another one, just like this one.
Is that our final answer?
That's our final answer. That's our interval notation answer. So just like on our last section, when we had our interval as our answer, that's what we're looking for, is that interval as our answer. So let's do the right-hand one. It has 3. So this would be some form of a cubic, which we could sketch this out. We've seen these kinds of things before. In Algebra 2, you sketch these kinds of polynomials. But it's also really easy to get signs kind of funky. So we're going to use our tables. So find our roots when it equals 0. So this one already is set equal to 0. So let's start with finding our roots or finding our zeros. So our roots on this first one, -2. Our roots on this second piece, +1. And our root on this third piece, 4. So I'm going to draw my little number line thing. And I'm going to put these in order, smallest to largest. So we're going to have our -2. I mean, I can close the window if it's causing problems. But that's, I think, the 8th graders finally getting their bus to leave. All right. So we take our number line. And we're going to put our factors down the left-hand side. So I'm going to do my x plus 2. Ooh, my screen jumped. On one line. And if you have lined paper, you don't have to draw that line. I just don't have lined paper up here. And we're going to have our x minus 1. And it doesn't matter what order we put these in our table, as long as we have all the pieces here. 4 minus x. Kind of making our table here. So think about a number that is smaller than -2. -3, -4, -5, whatever you want to use. So this factor here, will it be positive or negative? So if we use -3-ish, so that would be negative. How about this one? Also negative. How about this one? Positive. 4 minus -3 would be 4 plus 3, would be a +7. All right, then we're going to look for something between -2 and 1. Zeros between. That's an easy peasy one. On this factor here, it will be positive. The 0 plus 2 is positive. How about this factor? Negative. And on the bottom one, positive. How about something between 1 and 4? 2, 3, either one's fine. Both are valid. And you don't have to pick a specific value. If you can do it in your head, that's fine. But I know it's easier sometimes to think it was something. The numbers under here are not structurally important. I'm just writing it down so we can see it. How about this factor? If we use 2, is this positive or negative? Positive. On this one, positive. And on this one, positive. Last piece. Over here, something bigger than 4. You can use 5. So this piece, positive. This piece, positive. This piece, negative. So then we're going to look for our total function. We're almost done, I promise. Negative times a negative times a positive is going to give me what? Positive. Positive times a negative times a positive. Negative. Positive, positive, positive. Positive, positive, negative. Negative. So, looking back at our rule, our original equation, if I want to know when it's less than or equal to 0, which regions is it going to be? The second one and the last one, the ones that are negative. This is when it is less than 0. Are we going to be using brackets or parentheses on our zeros? Brackets, because it's okay if it's equal. So this is going to go from -2 to 1. That's this interval here. Joined with union 4 to infinity. And infinity always gets a parentheses. Okay? So that's how we're starting out 2-7. We will finish up 2-7 tomorrow. I put all the numbers up for 2-6 and 2-7. 2-6 is due tomorrow. 2-7 is due Thursday because I want to be able to get it back to you before the test. If you have missing quizzes, you need to get them in this week before the test. So I'm going to pass back all the quizzes on Thursday. If you have not taken missing quizzes by the end of class Thursday, it's going to be a 0. And it's just going to stay a 0. Okay? Huh? I mean, homework is always supposed to be like within a day.
Yeah.
Like, it is due tomorrow. You give it to me by Thursday, that'll be fine. Okay, so that's the vibe. We have less than a minute to the bell. We did it though.